I
All
take it
right, awesome.
my,
Sorry, it took me.
take it you didn't get my email this afternoon.
Oh no, I didn't see it. What was it?
That's okay. I had an appointment at 4 and I wanted to see if we could switch this, but I switched my appointment, so it's no big deal.
Oh,
Not a
I'm so
biggie.
sorry about that.
Not a problem. I just switched my appointment. I was going to switch class to earlier or um, tomorrow, but this is fine. I was able to switch my appointment. All right. And I didn't hear back from Henry either, so I don't know if he saw it either because I sent it to both of you guys because you are the only two that ever show up. So it's like, hey, all right. First slide. Did you see this when I emailed this to you guys?
Yes, I did see that.
Okay, now, if you go into the course, did you go into that button that I had previous AP test with answers?
I have not yet.
Okay, this is going to be an open, obviously an open book AP test. I would take a look at those problems because the answers are there from the past previous years. And I have to say that it's got to be similar. I mean, there is no question that the types of problems that are going to be on this year's test, and obviously there's only two problems on the test, right? Um, they've got to be types of problems where they find a lot of different things that they're going to put together. That is the only thing I can think of. Um, and next week we're going to be going over a bunch of different AP type questions. So I'm going to try to think through what I think the AP test is going to give you guys. I could be totally wrong. I mean, they could give you something totally different. But next week we'll just work on some free response questions that I think might be on the AP test. All right. Last week we were dealing with the ratio test, and the ratio test, when you think about it, is probably one of the coolest tests, and that's why I said in the beginning that if they would just give us the ratio test right off the beginning, it would take away all those other tests that we were using. So the ratio test is the one, if there is a test that you memorize, it should be this one, okay? So it says the limit as n approaches infinity of a sub n plus 1 over a sub n. If L is less than 1, the series is absolutely convergent, and hence it's convergent. If L is greater than 1, the series is divergent, and if L is 1, the series may be divergent, conditionally convergent, or absolutely convergent. So it's like, oh, okay, then I'm going to have to try something else. But this one test is pretty amazing. So let's take a look. This is a pretty tough problem. It says determine if the following series is convergent or divergent. Well, if I was going to do this problem, the first thing I always do is I always just do the n plus 1. So, oops, I better turn on my, so a sub n plus 1, let's put it down here so we'll just do it all at once. So that's going to be negative 10 to the n plus 1 over 4 to the 2n plus 3. Now, do you understand how I got 4 to the 2n plus 3 if I just added 1 here?
Did you reduce it? Yeah,
Well, all I
right?
did is I did the 2 and then the n plus 1, and then if you multiply this through, you end up with 2n plus 2 plus 1, which gives me the 2n plus 3. Okay, because wherever you see an n, you're just going to add a plus 1, right? And then this is going to end up being n plus 2. And then times, I usually don't write it as, you know how the formula is a sub n plus 1 over a sub n. Usually I'll just go multiply and then just flip this over. So that means I have 4, 2n plus 1, n plus 1 over negative 10 to the n. And that is obviously the limit as n goes to infinity. Okay, so that's a lot of stuff in there, right? Well, now I start reducing. Well, if I reduce the 4n plus 1 and the 4n plus 3, guess what? I'm left with 1 over 4 squared. And if I have negative 10 n plus 1 and negative 10 to the n, well, that leaves me with a negative 10 on top. Nope, that's a negative 10. So that crosses out. And then I have an n plus 1 over an n plus 2. So really what I'm left with is negative 10 over 16. And that doesn't, when we take the limit as n approaches infinity, and then times n plus 1 over n plus 2. Well, we know what the limit of this is right here. This is just 1, right? So really my answer is L is equal to negative 10 over 16, but that's the absolute value, right? So the limit is equal to 10 over 16, which is less than 1. So that means that this series converges absolutely. All right. Caleb, any questions on that?
Nope, I think I understood that pretty well.
Okay. I think as I said, the ratio test, I think that is the one test that you really need to understand. Okay, now this is a little bit different. It says determine if the following series is convergent or divergent. I mean, it looks like a fairly easy problem, right? So let's try this one. So again, I'm just going to do the ace of n plus 1. So that's going to be n plus 1 factorial over 5n plus 1 times, and then I'm just going to flip this. So that's going to be 5 to the n over n factorial. Now, this is a little bit tricky. In order to rewrite this, I can rewrite it like this. I can rewrite it as n plus 1 times n factorial, can I? Because if you did factorial, it would be n plus 1, n, and then n minus 1 and all that. So I could just rewrite this as this. Does that make sense?
Yes.
Okay. So then so this is going to be n plus 1, and then I've got the n factorial here. I still have the 5 to the n over 5n plus 1 n factorial. Okay, so those cross out. The 5n and the 5n plus 1, that's just going to be a 5, right? So I'm left with n plus 1 over 5 as a limit as n approaches infinity. Well, you put infinity in here, this is going to be infinity. So L is greater than 1, so the series diverges. All right. Any questions on that?
Nope, that makes sense.
Okay. All right. This week, we're going to be talking about Taylor and Maclaurin polynomials. All right. And what we're really trying to do, and here's the whole concept here. If I gave you a function like the sine of x, okay, the sine of x looks like this, doesn't it? What we're going to do, what the Taylor and the Maclaurin polynomial does, is it rewrites trig functions or any function that is not a polynomial as a polynomial. And what we're going to do is we're going to write the sine of x as a polynomial. What does that mean? Well, it's going to be something like this. It's going to be like 3x to the third plus 4x squared plus 5x plus 6. It's going to be a polynomial function that's going to correspond with the sine graph. And that is the whole concept behind Taylor and Maclaurin polynomials. What we're really trying to do is we're really trying to find a polynomial function that mimics a sine graph or a cosine graph or an e to the x graph. And the more terms that you use, the closer and closer it will actually fit that curve. Now, there is a whole nother ball game that goes with this when you start talking about error bound. Okay, but the error bound is not on our list of things to do, and that would have been something that we would talk about this year, because if we use, let's say we only use 2 terms, this thing might only fit like this. So then what the error bound does is it finds how much error there is with your polynomial function. And the more terms you use, the smaller the error bound goes. But if you see a problem that I give you this week that has error bound, you can just forget it. It's not part of the lesson, but I tried to put a lot of previous AP questions in on this week's assessment. So if you see something that asks for an error bound, just forget it. It's not part of what the AP is asking us to do this year. But they are asking us to be able to figure out what a Taylor and a Maclaurin polynomial is, okay? So constructing a series, that's what we're going to do, is we're going to construct a series that will lead us to that part. Now, a Taylor series and a Maclaurin series are exactly the same thing. The only problem is a Maclaurin series is generated when x is equal to 0. Oh boy, I don't know what that was. 1 second here. Hey, oh, never mind. Okay, sorry about that. It's just my wife coming home. All right, so what we're doing is we're going to try to, a Maclaurin and a Taylor series are basically the same thing, except the Maclaurin series is when x is equal to 0, okay? And here is the function that you need to know. It is f of 0 plus f prime of 0 times x plus f double prime of 0 times x squared over 2 factorial. Now, I could have put 1 factorial under here just so you can see what the pattern is, plus, and you should be able to take this series out of 0, x to the third over 3 factorial, and it just keeps going, dot, 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 all the way. So this is how we come up with our polynomial function. We just use this formula to find our answer, okay? So let's do an example. So let's say I wanted to find a series for sine or cosine, and we're going to construct this series when x equals 0. So the first thing you really want to do, and I don't know if I have a blank page here. Nope, I don't. The first thing you want to do is you want to find the value of the first derivative at each one of these. So you want to know what the sine of 0 is, because remember, the formula is f of 0 plus f prime of 0 x plus f double prime of 0 squared over 2 factorial plus f triple prime of 0 at x to the third over 3 factorial. Okay, so let's just take it out this many places. Okay, so sine of 0 is 0. So my first term in this function is just going to be 0 plus, well, my second term is going to be f prime of 0. Well, the derivative of sine is cosine, and cosine of 0, that was 0. Cosine of 0 is 1. So my second term is going to be 1x plus, now, okay, so this is f of 0, f prime of 0, f double prime of 0. So that is going to be negative sine of 0, which is still 0. So my next term is going to be 0 x squared over 2 factorial plus, and then I take the third derivative, so that's going to be negative cosine of 0, which is going to be negative 1. So my next term is going to be negative 1x to the third, that's a minus, over 3 factorial. Okay, so if I work this out, because we kind of want to reduce this down, so this is going to be 0 plus 1x plus 0 minus x to the third over 3 factorial. 3 factorial is 6, right? So the zeros really don't matter. So 1x minus x to the third over 6. Now that's only taking it out to, what do we do? The third derivative here. As I said, if we took it out farther and farther, we would have a much better model of what the sine looks like. So here is, I think they took it out 5 places. So you can see first term 0, then 1x, negative x, or minus x, 0x squared minus 1 over 3 factorial x to the third, pop, pop, pop. So here is their polynomial. This is, and usually they just leave the factorials in there. I don't, because it drives me crazy. So I kind of figure out the numbers, but a lot of times they'll just leave it in there. So this is the polynomial function that represents the 7th order Taylor polynomial. Okay, in 7th order, you got 7th degree here. And you can see that a lot of the terms just crossed off because they were just zeros in there. But now let's see how closely it represents the sine function. Okay, this is the first term polynomial. It doesn't represent the sine graph very well, does it? Here is the second Taylor polynomial, starting to get a little bit closer. Here's the third, or I'm sorry, this is the 5th polynomial. Look at how close it's starting to get. 7th, 9th, 11th. When we get out to the 17th term, look how close that polynomial function, that Taylor polynomial function, represents the sine function. That is what a Taylor polynomial does. It lets us come up with a function that represents, a polynomial function that represents any other type of function, sine, cosine, e to the x, you name it. If you take it out, and that's why I said, you know, the error bound is huge. If you said, oh, what's the error bound at x equals 2? Well, it's not even close, is it? But if you ask the same question on the 17th polynomial and you said, oh, what's the error bound at 2? That'd be almost 0, wouldn't it? That's why the error bound is so important, because it really, you know, if you can get an error bound really close to 0, you're really, that polynomial function is really getting close to the sine function. Caleb, does that make sense what we're doing here? That we're trying to come up with a polynomial function that represents a function that is, you know, like a sine function or a cosine function or something like that.
Yeah, it mostly makes sense. Oh, why do you need to do this?
There is no good reason to do it, but in the olden days, before we had calculators and we know how to take derivatives, the only thing they knew how to take was a derivative of a polynomial function. They didn't know how to take the derivative of sine, cosine, and all that. So they couldn't find the tangent line at a point like this. So what they did is they came up with polynomial functions, because remember, taking the derivative of a polynomial is super simple, right? So that is where it all started, because back when calculus was just being formed, they didn't have a way of taking the derivatives of other type of functions. They only knew how to take derivatives of polynomial functions. So that's how this all came about. Now, today, it's not even smart. We know how to take the derivative of all different types of functions. So this doesn't make any sense for us, but it is going to, I will say that there will be a problem like this on the AP test. I guarantee it, because there are so many questions they can ask off of these types of problems. And since they skipped the parametric section and they wanted us to make sure that you guys knew how to do Taylor and Maclaurin series, I'm almost positive it's going to be there. That would be one of my biggest things, is this is going to be on the AP test. I can't say that for 100% sure, but I would kind of bet it's going to be there, because it's something new that you guys haven't seen. Now, when you're not doing the function at x equals 0, it only changes the function a little bit, okay? So for example, it starts off the same way. So remember, we'd have 0 in here, but let's say it's not 0 anymore. We're trying to come up with a polynomial function that is not generated at x equals 0. So then it's going to be f of a, and then f prime of a, x minus a, and then it just goes the same way, f double prime of a over 2 factorial x. Instead of the x's, you're going to have x minus a, and instead of the zeros inside here, you're just going to have a, or the value that you're trying to come up with. So let's take a look at a problem for that. So let's say we're going to find the Taylor series generated by f of x equals e to the x at x equals 2. Okay, and let's take it out to the 4th degree. Okay, so the first thing I want to do is I want to take the derivative of this thing. Okay, so well, let's do so we want f of 2. What does that equal? We want f prime of 2. What does that equal? We want f double prime of 2, f triple prime of 2, and f to the 4th of 2. All right, well, f of 2. Well, that's just going to be e to the 2nd, right? F prime of 2 going to be?
Same thing, e to the 2nd.
Yeah, they're all going to be e to the 2nd, aren't they? When you think about it, because the derivative of e to the x is just e to the x. It doesn't matter how many times you take the derivative, it's always going to be e to the 2nd. So now if I'm going to write my function, first term, e to the 2nd, plus, okay, so now I have the first derivative, e to the 2nd, times x minus a over 1 factorial. I usually put the 1 factorial in there so my pattern holds true. And then e to the 2nd, x minus 2 squared over 2 factorial, plus e to the 2nd, x minus 2 to the 3rd over 3 factorial. I said we were going to go out one more, right? Plus e to the 2nd, x minus 2 to the 3rd, to the 4th over 4 factorial. That is it. That is how you write a Taylor series when x is not equal to 0. Does that make sense, Caleb?
Yes, I think so.
Okay, take a look at it. And it's a fairly easy pattern. And obviously, you guys get to use notes and stuff. So make sure you have your notes out on the AP test. Here is, this
A
is how they, yep.
quick question. Will you remind me why it's x minus 2 in the bracket?
Because we're not at 0 anymore. So the formula says, remember the first formula, if it's at 0, it's f of 0 plus f prime of 0 x plus f double prime of 0 and then x squared. Well, if it's not at 0, okay, then you have to, because we're no longer trying to get the function to be at 0. We're trying to get the function at 2. Well, how do you shift the function over to positive 2?
Oh,
Subtract 2, don't you? So that's why we
okay.
end up with f of 2 plus f prime of 2x minus 2. Because that just basically shifts the graph over. That's where we're trying to hone in. We're trying to make our polynomial function exact at this point. And really, if you look at this, this is only out how many places? And it's pretty accurate right there. I mean, if you went out to positive 3, it still looks pretty accurate. If you go out to positive 4, so it's starting to go off. And that's where the error bound is. The error bound is where it says, okay, we're trying to hone in on x equals 2. What happens at x equals 3? What is the error bound there? At x 4, what is the error bound? But that's something that, okay, so does that make sense?
Yes, now I think I got it.
Okay. Now, this was the 2013 free response questions. They, not too bad, but it will make you think about what's going on. Okay, so let's take a look at this, and then we're going to do the 2019 one also. I believe I have that one too from last year. Yeah, this is the 2019. So this is one that I think you're going to see something very similar to this one. Okay, so let's go back to 2013. It says, the function f has derivatives of all orders at x equals 0. Okay, so So now they're telling me at x equals 0. So now we know we're going to use the function f of 0 plus f prime of 0 times x plus f double prime of 0 times x squared over 2 factorial. Okay, so this is the one that we're going to use. This, because it's telling us that x equals 0. It says let p sub n, so that's our polynomial, denote the nth degree of a Taylor polynomial of f about x equals 0. Okay. Part A, it is known that f of 0 is equal to -4, and that p sub 1 at 1/2 equals -3. Show that f prime of 0 is equal to 2. Whew, okay. So what the heck are they really asking us to do there? All right, I'm going to give you a couple seconds and see if you can figure this out. All right, I'm just going to turn off my mic, give you a little bit of time because we have a lot of time to do 2 free response questions today. I really want to focus in on these. Okay, so give it a shot, see what you get there. All right. Did you show that f prime of 0 is equal to 2?
No, but I did a couple ways that didn't work, so I know what doesn't work.
Okay, so if I was going to do this problem, okay, p sub 1 really means that we have f of 0 plus f prime of 1, I'm sorry, because this is around 0, of x, okay? And they told us that that was equal to -3, right? All right. What does f of 0 equal? Well, they told us. F of 0 is equal to -4, isn't it? Plus f prime of 0 times 1/2, right? Because that's what that x value, that is what they're really telling us here, is that our x value is 1/2. And here they're telling us that f prime of 0 is equal to 2. So this is 2 here. This is 1/2 is equal to -3. -4 plus 1 is equal to -3. Ah, that is true. So that is how I would have done part A.
Gotcha. I totally missed the whole P sub 1 thing, which is super important, but I got you now.
Yeah, anytime you see P in a type of problem like this, they're basically telling you that that is your polynomial, okay? So like this problem here that says P sub 3. All right, so now I kind of understand that they want me to do like f of 0 plus f prime of 0 x plus f double prime of 0 x squared over 2 factorial plus, and then my third term there, right? So that's what they're telling me. X to the third over 3 factorial. All right, so when I see that, this is what I'm thinking. Okay, now let's see what else. All right, so it says it is known that f double prime of 0 is equal to -2/3. F triple prime of 0 is equal to 1/3. Find p sub 3. Well, guess what? We get to use all this information up here still to do this problem. So right now, I know that f of 0 is -4 plus f double prime, so that's -2/3 x plus, well, f double prime. Oh, I'm sorry. F double prime is negative 2/3. What did I do with F prime? We knew that up here, didn't we? Darn it. F, that's 2. Sorry about that. I messed up. F prime is 2. So this is going to be negative 4 plus 2x plus, and then the second derivative is negative 2/3. So that's going to be negative 2/3 x to the second over 2 factorial plus, and then my third one, that's going to be 1/3 x to the third over 3 factorial. Okay, so now I would assume that they probably are going to make you clean this up. So I would end up with negative 4 plus 2x plus, that's 2 factorial, so that's going to be a 12 on the bottom, but I have a 2 on top. So how about negative 1/6 x squared? I think if I did this in my head correctly, and then plus x to the third over 3 factorial times 3, so 27 times 3, is that 81? I'm thinking.
What does 2 factorial and 3 factorial mean? Is
2
it 2 to
factorial.
the second and 3 to the third?
Okay, I don't get what you're saying. What does 2 factorial mean? Oh,
Yeah,
oh,
I don't know how to do that when it's just a number.
2 factorial just means 2 times 1. 3 factorial means 3 times 2 times 1. 4 factorial means 4 times 3 times 2 times 1. Whenever you have a factorial, it just means you multiply all those numbers down to 1.
Okay,
So if I said, what is 6 factorial? Well, you'd have to multiply 6 times 5 times 4 times 3 times 2 times 1. That's what a factorial means.
okay,
Okay? So here, 2 factorial, that's just really 4. 4 times 3 is 12, but I have a 2 on top. That's why I came up with a 6 in the denominator. Okay? All right. So onward to the next one. Okay, let me get rid of this. Are you okay with that?
yes.
All right. So let's get rid of that. Oh, this was not right. 3 factorial is 3 times 2 times 1. That's 6. That's 18. Wow, where did I get 81? Holy cow. I'm sorry. I was taking it. I was cubing it. Woo. Oh, I'm sorry. Maybe that's why you didn't understand what a factorial was. I'm sorry. That should have been 18, not. Did I do this one right? 2 factorials, 2. Those cross out. Oh my goodness. I'm really messing up on my factorials today. Holy cow. I think I was taking it like 2 to the second. No. All right. That looks a little better. All right. Now, when you have a polynomial function like this, if they asked you to find, let's say that this is piece of 3, and they asked you to find the integral of piece of 3, what do you think you would do?
I have no idea.
All you do is take the integral of each term. That's it. If they asked you to find piece of 3,
Oh.
derivative of piece of 3, you just take the derivative of each term. That's
Mm,
it. So it looks, and I'll show you a problem on the 2019 that was just like that. And it's like, wow, this is like the easiest problem they gave us. But that's all it is. You can take an integral of a polynomial function just by taking the integral of each separate term. You can, if they asked you to find the derivative, you can take the derivative just by finding the derivative of each term. So you can do the same thing with the polynomial, once you came up with the polynomial, you can take the derivative, you can take the integral, all of that stuff is the same. All right, let's take a look at part C. It says the function h has a first derivative given by h prime of x is equal to f of 2x. Okay, it is known that h of 0 is equal to 7. Find the third degree Taylor polynomial for h about x equals 0. Oh, all right, you want to try this one on your own, or do you want me to work on it?
I can give it a whirl.
Okay, I'm going to turn off my mic. I'm going to let you take a look at it and see what you get, okay? It's a pretty good one. Stumped yet, or do you got it?
I'm kind of stuck on the f of 2x.
Okay. So what do I need to know in this problem? That's what I always come back to. I need to know what, oops, I gotta turn my marker back on. I need to know what h of 0 is. I need to know what h prime of 0 is. I need to know what h double prime of 0 is. I need to know what h triple prime of 0 is, right? Because they want a third degree polynomial. Well, I know what h of 0 is. They told me it's 7. So right away, I know that this is going to be 7 plus something to the x plus something to the x squared over 2 factorial, which is just 2, so I'm not even going to put factorial in there, plus something x to the third over 3 factorial, which is just 6, right? So I just need to
Yes.
fill in these pieces right here.
Hmm.
And that's where it gets a little difficult. I know h prime is f of 2x, so I'm just going to put that in there. Okay? Then, what is, and then I suppose I can plug 0 in there, so that's going to give me f of 0, right? And I believe I can safely say that we know that f of 0 is -4, right? So I'm going to put -4 there. So I've got 7 plus -4x plus, well, we got to figure out what this is. All right, so I'm going to take the derivative here. Well, the derivative, h prime, isn't that, so this is h prime, f of 2x, isn't that 2 times f of 2x? Because we take the derivative, leave the middle alone, times 2. So isn't this my second derivative? Isn't it 2 f prime of 2x? Does that make sense?
Yeah, but you still have f prime of 0 because 2 times 0 is 0.
Right. So f of 0 is uh,
F prime of 0 is 2.
f prime of 0 is 2. Okay, I'm looking all over for it. It's right there. So really, this is going to be 2 times, so 2 times 2 is 4? Is that right?
Yes.
So that's going to be 4x squared over 2, which is just 2x squared, plus, all right, now I'm going to leave you to find h triple prime. Okay, so what is that going to be?
So you chain rule 2f prime 2x, and that makes 4f double prime 2x. X
Yep,
is equal to 0, so you get 4f prime of 0, f double prime of 0. F double prime of 0 is negative 2/3, so it's negative 8/3.
correct. So now we have negative 8/3 here. So that's going to be negative 8x to the third over 18. Is that right? I think. Which probably can reduce to negative 4/9 for this term. So negative
Yes.
4/9 x to the third. So that wasn't too bad, right?
No, no. Yeah.
All right. So let's take a look and see what the point values were for this problem. So part A, 2 points for coming up with f prime, or showing that f prime of that piece of 1 was equal to negative 3. And then this was our equation, and I believe this is what we came up with for number 4. And look at that, 4 points for that thing. Sweetness. I can almost guarantee you that there will be a problem like this year. I just have that feeling. Okay. This was the problem from last year. Okay. Now it's very similar to the last problem, but they give you values over here. They give you some values over here. But I thought it was I looked at it and it's like, oh, that's a pretty decent problem. And this was last year. And usually they're fairly similar from year to year. Okay, so this one, it says a function f has derivatives of all orders for all real numbers x. A portion of the graph of f is shown above, along with the tangent line to the graph of f at x equals 0. All right, x equals 0. They're talking about, so again, I'm talking about f of 0 plus f prime of 0 times x plus f double prime of 0, x squared over 2. Okay, so that's what they're dealing with. That's why they tell you x equals 0. Part A, write a third degree polynomial for f about x equals 0. Okay, so I am going to turn off my mic now. I'm going to let you write a third degree polynomial about x equals 0. All right, so right about here. Boom, that's where you're going to write your third degree polynomial. All right, so I'm going to turn off my mic. I'm going to let you work. All right, what'd you get?
I'm almost done.
Okay,
I just have to do the third one.
all right, give me the first 3 terms that you have.
Okay, f of 0,
Now,
or
give it to me in
sorry,
polynomial form.
the first one is 3.
Okay,
The second one is negative 2.
okay.
And the third one is it 3 times 2 squared over 2?
3 times,
Is x, no, x is equal to 0. Because
right.
there's the x squared, right?
Okay, so what you really want to find is f of 0, which you did. You found f of 0 was equal to 3, correct?
Yeah.
And then you need to know what f prime of 0 is equal to. What does that equal?
-2.
Right, and you just found that using the tangent line. Pretty tricky of them, right? Then you need to know what f double prime of 0 is equal to. Now you have to use the chart. Okay, so what does the chart say?
3.
And then we need to know what f triple prime of 0 is, and that is?
-23/2.
Okay, now, remember, this is this value right here. That's what goes in for that value. So when I rewrite this, f of 0, I'm just putting 3 here, plus, and then f prime of 0, well, that value is -2, but I still have this x here, right? Plus, f double prime of 0, well, you said that was 3, right? Well, we still have the x squared and the 2 factorial, which is just 2. And then f triple prime, that's -23/2, but that has x to the third over 3 factorial, which is just 6, right? So this is my whole answer. Now, I probably would make this a 12 here on the bottom, but
Oh, right. Okay, so you don't put any numbers in for the x.
no, that is
Oh.
because if you put numbers in for the x, it's no longer a polynomial, right?
Okay,
That's
you're
what
right.
makes it a polynomial function, is that you've got the x squared, x to the third. That's what makes it a polynomial function. You do not want to put a value in there.
Gotcha.
Okay, so that is absolutely correct for part A. So that wasn't too bad, right? And as I said, I believe that's going to be very similar to this year's test. All right, part B. It says write the first 3 non-zero terms. So this one, it asks us to write a third degree polynomial, right? So we had to keep going until we get the third degree. All right. If they asked me to write a fourth degree, I'd have to go until I got x to the fourth. But this time it says write the first 3 non-zero terms. Okay, non-zero terms. So I will only actually have 3 terms. It might only be x squared, but if you ended up with a 0 in there someplace, it could be even more. But it says write the first 3 non-zero terms of a Maclaurin series for e to the x. Write the second degree Taylor polynomial for e to the x f of x about x equals 0. So there's really, this should really be part B and C, to tell you the truth. I mean, they've got 2 questions in there. You have to answer two things. Now, previously in years past, they told students that there are some polynomial Maclaurin series that you can just memorize, okay? That you don't even have to know, you can just memorize. But e to the x is a pretty easy function to come up with, right? Because f of 0, f prime of 0, f double prime of 0, what are they for e to the x?
They're all the 1.
Correct. Okay. So if I was going to write a Maclaurin series for this thing, it's just going to be 1 plus 1x plus 1x squared over 2, right? So they said you could memorize those and just, you don't have to show your work, but really it's so easy to come up with e to the x. It's not even, I mean, my next term would just be 1x to the third over 3 factorial, which is just 6. So I could just keep going on and on if I wanted to. I mean, that is a pretty easy problem to do. Okay, so that takes care of part A. Then it says write the second degree Taylor polynomial for e to the x f of x about x equals 0. Okay, so now we're putting these 2 functions together. Whew. Wow. E to the x f of x about x equals 0. That is a pretty difficult problem. I mean, it's not difficult, but it does take some time to do, because when you think about it, you're going to have to find all of these terms. So when you think about taking the derivative, oh my. So let's get the first, what does it say? Write the second degree Taylor polynomial. Okay, so let's find the first term. Well, the first term is just, let's just call this, I don't know, we'll call it f again. So what's the first term? If I put 0 in here, I put 0 in here, what do I get? What's my first term?
Your first term is 1 times 3, 3.
Yes. So boom, we've got our first term. We have to do 2 more, right? Because this time it's asking for a second degree. So that means we have to go all the way down to f prime of 0. That gives us a first degree. F double prime of 0 gives us the second degree, right? So let's only do the first. Let's do just the first degree because it's going to take some time. Well, I have to take the derivative of this, don't I? So I'm going to write that up here. So u prime, v prime. What am I doing? I'm doing the product rule. So u is equal to e dx, u prime is e dx, v is equal to f of x, and v prime is f prime of x. Okay, and that's at 0. So that's just going to be 1, 1. What do we say f of x was? 3. And f prime of 0 was that negative 2? I think it
Yep.
was negative 2. Okay, so I can just use my values here. So if so 1 times 3, so that's 3 plus negative 2. That looks like 1. So that f prime of 0 should be 1. So my next value should be just 1x, if I'm not mistaken. For that?
Mm-hmm.
Okay, so that would be 1x. Oops, what do we? So we ended up with, so my answer is 3 plus 1x plus, now, if I really, because I can't use numbers if I'm going to find the second derivative. So the first derivative is e to the x f of x plus e dx f prime of x. So now, do you see where the problem is? If we want to find the second degree, we've got to take the derivative of this and this, which I guess isn't that difficult because we already know what the value here is, right? Because we already took that. That should be 1. But I still have to take the derivative of this, so that's going to be e dx, f prime, f double prime. Okay, so let's see if we can do this. So 1, 1. F prime was negative 2. F double prime was 3. That's not too bad. Negative 2 plus 3. Oh my goodness, it's 1 again. How crazy is that? So I don't even know where my answer is anymore. I think it's up here, isn't it? So that's going to be 1x to the second over 2. So I believe this is the answer.
Well, it's e to the x f of x also, so it's 1 plus 1, right?
Well, it's because remember when you take the derivative, it's you're right. So it's 1. Oh, thank you. So then that's going to be a 2 here. Those 2's cross out. So really my whole function is going to be 3 plus 1x plus x squared. Oh,
That's not
that,
that bad.
no, it is not. But you think about how many kids would not be able to get that problem right. I mean, that is, to me, that's a tough one. Now, letter C, it says, let h be the function defined by h of x. Okay, so where's h of x? I think we did that. That was this first one, wasn't it? Right, a third? Nope. Oh, okay, never mind. That was problem 213. Okay. H of x is equal to the integral from 0 to of f of t. Use the Taylor polynomial found in part A to find an approximation of h of 1. Okay. So if I wanted to find the approximation of h1, don't I, is this my equation here for, is this our answer for part 1, for part A? I think this was it. Okay, so I'm going to take an integral. So that's going to be what? 3x minus 2x squared over 2 plus 3x to the third over, so 3x to the third over 3 times 2. So those are going to cross out. And then you're going to have to take the integral. Once you get your value, you're going to have to go from 0 to 1, right? Because it says find the approximation of h of 1. So as I said, I can take the integral of any polynomial function, and I don't want to have to take the integral of this. Sorry, that's just asking for trouble trying to take the integral of that. But here, let's take a look at the answer key. Here's the answer key for last year's AP test, and this was problem number 1 that I think you almost had, except you wanted to plug some values into x, which shame. This was the first part of problem number 2. I think we wrote it a little bit different because we didn't have 2 factorial. We just did 1 plus x plus 1/2 x squared, which is the same thing. Problem number 3, I think we had that for our answer. And problem number 4, I guess I should have looked. That's the integral of that last term. And then you just have to plug in your values, and you'd end up with 97 over 48. Some pretty interesting problems. But I will say that I am going to almost guarantee that they wouldn't have told us that we had to go on to this section if there wasn't going to be something about Taylor or Maclaurin series. There wasn't anything about error bounds yet, which they didn't ask us to, but I'm pretty positive that they're going to have a problem like this year. All right, it is almost 5 o'clock. Caleb, any questions?
No, I think I'll do pretty decent. I think I got it.
All right, and next week, all we're going to do is I'm just going to bring a bunch of AP questions in, and we'll just work through them. And then the following week is the AP test. 2 questions. That's it.
Yeah.
I just cannot believe that. That's going to be crazy. But remember, you are on a computer. You can use anything you want. And that's the key that you have to remember is everybody has, I don't know if you have I mean, we don't have textbooks. A textbook would not be a bad idea to have in front of you when you're taking a test, because it would have all the derivatives, all of the integrals, and all that kind of stuff. So, but you're good at computers. You'll be able to look stuff up. It's one of those things where you know darn well that other kids are going to be using all of that, all their resources too. So you gotta play smart. All right, Caleb, you have a great week, and we'll see you next week.
All right, you too. See ya.
All right, bye.